Hi, welcome back. So we are in section 3 in Object-Oriented Comprehensive Guide in Python. In this section, we shall be discussing objects alike and in particular speaking about inheritance and one of its features called polymorphism. So before we navigate further, let's talk about some of the outline we will be discussing in this section. In the first outline, we will be taking a quick tour on the concept of basic inheritance. Actually, one of the most strong concepts when it comes to apply object-oriented for your project. Then we will be talking about multiple inheritance. Following that, we'll be talking about one of the features associated with inheritance, that is polymorphism. And then I'm going to be talking about the abstract base classes, how to actually create and implement them. And of course, finally, we're going to be looking at a case study to recap everything. So let's go ahead and start with the first outline, and that is to discuss basic inheritance. Number of the point we are going to be discussing in this outline. First, we'll be looking at the comprehensive introduction to inheritance with some practical example. So I am back here to Visual Studio Code, and I have created this section 3 folder, which is going to contain most of the actual code we're going to be working along the line. Now, basically, every class we create use actually inheritance. All Python classes, in fact, are subclass of the special class named object. Let me show you, if you would have to come to the interpreter here and just enter to Python interpreter mode. Now inside interpreter mode, let me use help and call this particular class called object, which is by default, every object we create, actually, every class we create, actually, it inherits the characteristic of this particular class. You will see the tree that we discussed before due to the doc string has been made once this class was created. So for example, you can look, there are more than 90 subclasses out of this particular big class called object. Each one of them has particular actually functionality. Some of them we override, some of them we use, etc., etc. So I wanted to show you the ability to look beyond the box of just actually writing a piece of code, but rather than to understand exactly what is happening behind the scene. Now, in fact, if we create any class, for example, saying this is my class, right? Usually we used to write that way. My class, by default, actually inherited everything from object to class. That's why I enjoy a lot of characteristics that object class are available there. Now, in this case, and from terminology perspective, my class is, in this case, will be called the child class, or actually it could be called the subclass. Object will be the base class or the main class, the parent. There's so many names out there. But one of the names that most probably you will hear quite often in Python called the superclass. So object is superclass to my class, which happens to be the child of that class. And that does not, of course, prohibit me of making another class down there. And this class will be, for example, a second class, whatever. And this particular class can inherit actually from my class again. Now, my class is the superclass for the second class, but object is superclass for both. So this kind of structure or idea must be very, very clear to you. Now, let's try to put everything together in a practical example that might show us some basic idea about inheritance. Let's start with a simple contact manager application. Will track names and email address of several people. Now, the contacted class will be responsible to maintain this list of all the contacts. So if I would have to create a class here, and let's call it as the name intuitive contact, okay, and of course we'll inherit from object by default. Could go to the initializer and just say in the initializer, whenever you want to instantiate an object of this class, I want you to provide me with name maybe and email, and then I can create a variable here. Let's call it the name, right? And I will set it to the name you give it to me. So this self.name will implies the object you are instantiating will carry that name, and self.email will be equal to the email. Great. If I would have to instantiate a contact object, I would have to actually provide these pieces of information, which is the attribute in this case, name and email. However, you could see now, I would like to have this contact manager to be a book that holds all these names. So what I could do, I could take this object that we instantiated and I save it somewhere. Usually we save it in a database. However, for illustration purpose, what I'm going to do, I'm going to assume large list and I put every object instantiated inside that list. Now, the question is that the location of that list. We have seen what you call a class variable. So if I would have to create something here, all contacts, and just I will use it as a list. So these two open brackets, as you most probably know from prerequisite, it represents a list in Python. It can be reached and read all the time. It's not per object. That's why you can see it is not followed by something called self at all, because it's seen by the whole, by every object has been created. So maybe I can take advantage of that to make it as a placeholder where every object is instantiated will be added there. Go to the contact, the main class itself, right? And I say dot. Now you can see it's available to me as a variable or as an attribute. And then I can use the append built-in function and I will add the self. It means the object that has been just instantiated will be added automatically there. Let's actually try to illustrate that, create a contact one. Contact one will be just contact to provide the name and the email, the two variables here. And I can create as many objects as I want, of course. So I can change this second object. If I would have to print the contact.all list or all contact, I should be able to see inside this list what do I have. Now I'm going back here to my terminal. So let me go and run that. Here is the result. So we have this list that contain two objects. This is one object and it's a second object, which is we have just created here. These are instantiated from this main, which is actually the main module name, and from this class called contact, and this is the address of this object, and same for the second one. Now let me give you a scenario here. Let's assume we have different type of contacts, right? Friends, they are my contact. I have clients. I have suppliers. Now this class does not differentiate. He just take name and email. For example, have one type of my contact is a supplier. And supplier means he provides a certain order. You might tell me, okay, go to the contact in this case, add a new functionality and call it order. And then you can take whatever the order you want, etc. But there is a problem here. Now, if this function or this method is created within contact, it means every type of contact will have access to that particular method. And I don't want this because a friend has nothing to do with order. That's why what I would do, I would create another class. So in this case, let's create a class that is actually related to suppliers. Now here is the interesting part of inheritance where it becomes really strong. I know that every supplier is a contact, right? Every friend is a contact. So now when I say is a, it inherits already everything from contact. In this case, supplier can be actually a best example to inherit everything from contact. Now contact is a super class to the supplier, which happens, or the parent, which happens to be for the child or subclass called supplier. Inside supplier, I can now create the order method that just only belong to suppliers. In this case, of course, I will not forget the self, and I will say I'm gonna receive an order from the supplier if you want to use this functionality on a supplier contact. Now what will happen, for example, just let's make a simple print function here. Your order is something like that, and let's now take actually the order that's been passed, and your name is. Now where we're gonna get this name? I can get the name, you know, from where it's directly, as you guess, from the super class or from the parent class. So if I would have to say self dot, now this is the object instantiated from the supplier, will have access to every variable and method that is available on contact. So in this case, I could just say from your name. Now I am creating actually a contact for me, but this time I will not instantiate directly from contact. I will go to supplier. You could see now I am prompted to ask to provide name and email because now these functionality are from contact. So in this case, I will say supply one, and the email, of course, is going to be. Now, interestingly enough, if you would have to go back to the terminal, try to run that, you will see now I have 3 objects. So we have object from contact, another object from contact, DHT, and another object from supplier. Now, interestingly enough, if I would have to attempt to go inside one of the C1, one of the objects, and try to reach to this function called order that we have created here, I can't see it because order cannot be seen by the actually subclasses that is inherited from the main class. However, if I would have to go to S1 dot, now I can see the order class. Why? Because only supplier can have access to that. So if I would have to run this, for example, let's say my order is software apps. I got your order is software apps, which is taking the text I provided, and your name is supply one, right? It takes the name. Now, what is this none? Why it happens? Because I'm printing it again. So this was a print from the inner function, and when it went out and print again, this is not gonna be the right way to do. So I should have actually just directly executed this line, then I will not be seeing that none again. Great. Now, this was a comprehensive introduction to inheritance from different perspectives. Let's look at the second subject, and that's to talk about extending the built-ins. Let's first of all define what do we mean with the built-ins. One interesting use of this kind of inheritance is to add functionality to the built-in classes. Now, if you look at the contact class we just created here, we are adding contact to a list of all contacts, right? Every contact we add, it doesn't matter as a supplier or a friend, whatever, or directly from the superclass of contact, it's added to this all contact. What if we also want to search that list by name? We could just add a method on the contact class to search it. But it feels like this method actually belong to the list itself. In other words, to say I want to execute the search not for the contact in literal, but I'm talking about only the contact list. We could come here and we create completely a new class. I will call it very intuitively with its name contact list. And this contact list is going to inherit, but from whom? I will call the list a class. And next, I'm going to define a specific function here, that the one I was talking about. Let's call it search actually. And of course, it's going to take self, and then it's going to take a certain name. So I want to search about name, right? What is my strategy here? Well, I'm going to create a list, matching list. And now I'm going to make the condition or the actual algorithm of searching. So I would say let's call contact in the self. This self will implies actually the actual object that I'm passing or instantiating from this class. And it's going to be actually a list by inheritance. I want to check if the name that you just passed to me is inside the contact dot name. Why I know this is going to be part of this, you will see in a while, because I know that the contact or the object, it has this attribute called name. Right. Then what I'm going to do, I will add that to the match list.append contact. And anyway, return at the end this matching list. Now remember in our example down here, when we created a contact class, we come up with all contacts and we were directly using a list class. But this time we're not going to use list class. We'll use contact list class. This is very interesting. Now, all contact, it has its own built-in feature with the search. This is a very, very powerful mechanism. So what we can say, we have just made some editing on the idea of creating a normal list to a list with a search feature in it. Now what I'm going to do, I've created like these two different objects from contact directly and one from suppliers. I'm going to open and print down a return kind of a search. So I will call here a C contact. I mean, by the way, this comprehension way of writing a function in Python, I assume you do know it, though I will be talking about it in future sections. Anyway, so I create a variable called C. What is this C? C is going to be, if I hit back to contact.all contacts, you remember this is a variable. Now watch carefully. If I click on all contact, I have now a number of built-in functions. One of them is called search. Now this search, make no mistake, this is the search that I have just created within here. Okay. So be careful, I'm using this search. And now search will ask me to provide in particular a name. Which name you want me to be adding here? Let's take about, for example, 1. Don't forget the search we have just created is gonna go and loop inside the contact list, which is we attach all these inside, and he is going to be searching inside every one of them inside the name. Once he match with the word that I provided down here, he's going to actually add the object itself there. Now, I think if I run this, if I print this particular new list, the return out of it, I should have two objects because one happens to be in this C1 and one happens to be in this supply one. You can see we have two objects, one from the supplier and one from the contact. Yes, it found because I matched here. So what we have done, or what is the takeaway from this particular point, that we have actually made an amendment on the built-in kind of a list that you have seen just now, and we added this feature called search. And now we enjoy actually access to this functionality anytime that we want. And by the way, I can do exactly the same thing with every other built-in class. For example, I have here lists. Sometimes I might have dictionary. Sometimes I might have a tuple. So whatever kind of a built-in class, I could have the same functionality available. Now, finally, we want to talk about this point of overriding and superclass in Python. As we said, inheritance is great for adding new behavior to existing class. But what about a changing behavior? For example, our contacted class allow only name and email address. This may be sufficient for most contact, but what if we want to add 4 numbers, for example, for certain contact? So once again, it's a specific functionality. Let's say I have here created suppliers. I have a different class. Let's call a close friend. And this close friend, again, will inherit from the class just like suppliers. By default, from contact, he will taking the name and the email. But I want him to also take a phone number when instantiating as a close friend. So you could say, well, self.name equal name, just like we did up, self.email equal email, and self.phone equal phone. Great. Now, this syntax, what we have done here, we did something called overriding the init. So the official init, since I inherited everything from contact, this is the init, right? The initializer, remember this class we took, dunder init. Now what I did here, I just override that one by writing again the name and email. But this should not be happen to init. We cannot really think to override init. And once you see this kind of static code, you know the code that does not really know what he's doing. However, we need to add some problem in this example. Our contact and friend or close friend classes have this duplicate code. It's very obvious. I mean, this is name, email. Again, I'm duplicating the code. That's why what we really need is a way to execute the original init. I mean, this original init, where we don't want to actually rewrite it down here in a close friend, but with adding also the phone. So I want the object initialization recognize adding the phone as if it is from the init. This is what the super function does. So there's something called the super function. It returns the object as an instance of the parent class and allow us to call the parent method directly. Now this super method implies the contact. I will dot init, its own init. And what I want you to do, I want you to consider the name, and I want you to consider the email. So what I'm trying to say now, I am telling him whenever I instantiate close friend and he added them, just take whatever name and email and assume that. So this is an instance created as if by the contact class directly. And now it is my time, just add one more variable, given the fact that I'm instantiating from close friend. This is what I can say now. Self.phone is going to be equal to the phone. If I would have here to say CF, for example, close friend, and I would have to say close friend, watch carefully now, it requests me name, email, and phone. However, if I am instantiating from suppliers or from the contact name, just I have name and email. So this phone will only show up in this particular case. Be sure this super call can be made inside any method, not just on it. This means all method can be modified via overriding, and we call to the super. So it's a very powerful. We will have a few examples to implement that along the line. Let's go now and discuss the second outline, that is multiple inheritance. I will see you then.